Hey, how's it going, class? Welcome. Today you're going to be working through this video, going through our lesson for the day. A huge part of this next unit, really just from here on out, is algebra. You need algebra skills. If you don't have them, you need to build them. If you need help doing that, come talk to me. I will gladly help you out with that and do my best to get you to the point where you should be by this point. But the other thing you can do is you can go on YouTube and you can look for videos. I guarantee you can find a video of any single type of person you want teaching it. Try a bunch of different ones, see which ones stick. But you need to be really good at those algebra skills, especially solving for x and combining like terms. So take a moment, work on these problems in your notes, and come back to the video once you have an answer for all of these. So looking at this, we need to divide by 15. Now, the hope is that you just instantly kind of look at this and you go, okay, there's 3 15s and 45 because we've got 15 minutes and a quarter of an hour. 45 minutes is 3/4 of an hour. Hopefully you're kind of starting to see that and you're starting to use the numbers in your real life. The other thing you can do is you can take and factor this. That this is 9 times 5 over 3 times 5. Well, anything divided by itself is 1. So 5 over 5 just becomes a giant 1. And then 9 divided by 3, well, we know that that is 3. And we get our value. And these should be second nature. These should be something that you're kind of just looking at and working through. That we're adding that 9 to both sides. And we get x equals negative 12. These are our one-step solving because it took one single move to do it. Then we've got over here this one. This is our beginning of 2 steps. So we add our 9 to both sides. 2x equals 20. Divide by 2. And we get x equals 10. And we just kind of keep going with this idea. We take and combine like terms. 4x minus 2x is 2x. Minus 5 equals negative 3. Add our 5. We get 2x equals 2. Therefore, x equals 1. And we're just kind of going through this. Next up, we're going to take a look at this vocab sheet that you will be handed. Or if you haven't, you can just do this in your notes and put it in the sheet later. But we're going to be looking at just the first kind of section of the line angle vocabulary sheet. So our first word here is angle measure. This is just the numerical value we use to describe how big of an angle something is. Kind of like how we use a ruler to measure a distance, we measure angles by using the primary unit we're going to use is called a degree, blank degrees, which hopefully you kind of have a feel for it. There's 360 degrees in a circle. And we measure basically how much of a circle can we fit here. We will often use the Greek letter theta here. That is theta. This is a Greek letter. We use Greek letters a lot of times to describe angles, especially theta. Theta is usually an angle measure. Another one we'll use is phi for times when we're trying to describe multiple things. But here, these are Greek letters. Mostly for angles. Now, you will see them other places to describe different functions. For instance, in probability and statistics, if you keep going with it, when you get to high-level probability, you get what's called a binomial distribution that has parameters n and theta. where n is the number of trials, and theta is the probability of success. So we do use them other places, but it would not be an unfair guess if you see it out in the world. It's describing an angle. Next up, we've got our complementary angles. A complementary angles grouping is a pair of angles that add up to 90 degrees. And we note that they can be attached or not. So what's this look like? Well, you can have kind of the stereotypical one where they're attached. Where you have this 90-degree angle here, which we'll denote with a little like L in the corner of it, where we've got theta and phi. And what it means that they're complementary means that theta plus phi equals 90. Now you notice they say very particularly they can be attached or not. So we can have two angles like this, where we take that same kind of look and we just break it apart to where now those are two separate things. It's still the same scenario where theta plus phi must equal 90. For example, if we pick, say, 30 degrees plus 60 degrees, that is 90 degrees. So this would be a complementary angle. The stupid way that I like to think of it, if you're sitting there and your friend is sad, they usually kind of are bent over. Maybe they got a little tear on their face, like they're not happy. You come up and you go, hey, you've got really nice whatever. Hey, you're a great person. You're sweet. You have nice hair. Dude, your arms look huge. Whatever it is. And your goal is that you want them to stand up straight and be happy. It's stupid, but we compliment, slightly different verb there, compliment each other to get us standing tall. Same thing here. Like I said, I know it's stupid, but here's a secret. Sometimes the stupidest things you hear in class are the only things you remember. So when we have this, that's a complementary angle. Next up, we got our supplementary angles. Well, hopefully you have one guess as to what this number here is not. It is not 90. So when we see supplementary, I like to think of it this way. When you are trying to take care of yourself, a lot of times you start taking vitamin supplements. Well, a supplement is to make up for the fact that you're not complete. You're not a full, flat amount. So when we have this angle here, this is a 180-degree angle. This is what we call a straight angle. So a supplementary angle is two angles that add up to 180 degrees. So we can get that both, notice, attached or not attached. We can have our straight line, and we can have theta and phi. Theta plus phi equals 180. And that's just as true if we have two angles like this, where they are not attached. Both are true. Really common one, we can have like a 145 plus 35. Whoops, yep, 35. to give us a 180-degree angle. And we can just kind of build anything like this. Whenever we're using these definitions, it's really important. These definitions really matter, and it'll make these problems way easier. A linear pair, think about that. We've got linear, while a line usually looks like y equals mx plus b. And we draw it like this. We've got a line, and well, what does pair mean? Well, pair means two. So we've got two lines here. So we've got angles that add up to, well, looking at this, I've got a full rotation. I've got 360 degrees. And clearly, these must be attached. And we can kind of go through and look at this, that we've got theta, phi. Actually, I'm going to do this a little differently. Theta 1, theta 2, theta 3, theta 4. So they tell us that adjacent angles are supplementary. So that means any angles that are touching. So when I look at this, like theta 1 and theta 2 are supplementary. Theta 4 and theta 1 are supplementary. Theta 4 and theta 3 are supplementary. And 2 and 3 are supplementary. So that tells me here that theta 1 plus theta 2 equals 180. Theta 1 plus theta 4 equals 180. And I can build this whole list of relationships here of things that equal 180. And I'm going to use that here in a moment, but just think about that word adjacent. If I were going to quickly write a definition, I would say that definition: two angles are adjacent if they share a ray. An array is just a point with a line segment that extends out infinitely far in the other direction. Last definition here, I'm actually going to take this picture, copy it, and we're going to use it over here because this gives us angles that are vertical angles. Vertical angles are angles opposite each other formed when lines intersect. So here, theta 1 and theta 3 are vertical angles. And theta 2 and theta 4 are vertical angles. And what's cool is we know that these then are equal. Theta 1 equals theta 3. Theta 2 equals theta 4. So we're kind of building out this list of, okay, well, we know these are equal. We also know that theta 1 plus theta 2 equals 180. But also, then, we can do all this other stuff, that theta 3 plus theta 2 equals 180 by substitution. And we can build all these really cool ideas from these definitions. So we're going to go into some practice time working through some of these problems. You can pause the video right now. I want you to just kind of take a look at those questions on the sheet in front of you.